Hi, I thought a quick YouTube video explaining the words color dataset might be helpful. So let's just quickly go through it. Along the top we have each of the words we presented to participants. Heavy, towering, huge, airy. They're all quite big words at the start for some reason. Oh well, it's just statistics. Petite. Now, we had 118 people do the study. I've just hidden a lot of their data. Oh, so sorry. So each row is one participant's response for example, dense, green. They chose green, black, dark grey, etc. to represent the dense word. I've just hidden lots of rows to make life easier for us. And also here we have red. One represents a heavy word, 0 represents a light word. Okay, if we go the whole way over, we have 40 words if I recall. We have a list of all the colours down here. Purple, blue, green, etc. All I did was I computed how many times out of all the people for the word solid did people pick purple. 3 times. Whereas people pick black 76 times. Okay, so fairly straightforward, fairly simple. We now have, in the next couple of rows along, sorry, columns along, I summed up over all of the words the number of total times people picked purple for when the words were light, sorry, that should say light, and when the words were heavy. So for purple, over all the words, over all the people, purple is picked 59 times for light words and 145 times for big words. So you can get an indicator here of that perhaps purple is a heavy word, in contrast to, say, white, which has 465 pickings. That's not a good word, but it's been chosen 465 times to represent the different words of all the people for small words. Anyway, first of all let's compute an index of relative lightness, and this is super simple. We take this value and we divide it by this value, and we get an indicator of how light the stimulus is. If it is above 1, we have a light stimulus. If it's below 1, we have a heavy stimulus. So here we have light grey being 6, pretty heavy. Where's black? Black's surprising there. Very surprising. Pause it. Sorry, I had to pause it. I thought I'd gone temporarily mad. So yes, the smaller the value, the lighter the sorry. If it's below 1, it's heavy. If it's above 1, it's light. So black is the heaviest. Dark grey is also pretty heavy. Red is surprisingly heavy as well. Whereas white is light. Okay, so I took data from the rainbow drag task. It's an index of how relatively light the stimuli are. So let's look at black. Black, if the value is below 1, it's heavy. Sorry, below 0, it's heavy. If it's above 0, it is light. So black is pretty heavy in contrast to white, wherever that is, which is pretty light. Now what we can do here is we can just correlate this column with this column, and we get a value of 0.74417, and that's probably a very healthy correlation, alpha, I would imagine, and imagine we got quite a nice low p-value there. I'm afraid I can't remember the formula, but I do know Kirsten knows this formula because I actually started computing correlations in Excel because of her. But anyway, you can ask Kirsten, who knows that formula. I can't remember it. It's something simple. Use dist and I can't remember. Let's quickly go look at the rainbow drag. How I computed this index here. So rainbow drag. I think we did something. I did something similar in the rainbow drag. So recall in rainbow drag, people drag the colours over a bar. So we have a box, and people put the, for example, light colours here and heavy colours here. We also flipped it randomly. So sometimes people place the light objects on the right hand side. Okay, just to specify that when people did place when the box was specified as the left hand side being the light side, that we have a 1 here. This is all the people's data. If I unhide this, you can see that there is indeed a huge amount of data. And through a lot of Excel hocus pocus, I've transformed these values so that they're all along the same scale, as it were, such that heavy is now always on the right hand side of that box. Okay, so we now got all of these values. Purple, now I don't recall the exact dimensions of the box. It says somewhere checker width of 740 pixels. So anything at the low end is light, for example purple. Am I right there? Well, anyway, and anything heavy on the right hand side, it doesn't matter. I've systematically done the same thing for all of them anyway. But what we can find is that we take an average of all of these values, and then we get like an average weight of that particular color. So here are the averages for the colors. So we have white being very high up, and we have black being very, very low down. I would imagine that I've simply mislabeled that. Rotation stimuli where heavy label is on the right. So it should be where heavy stimuli is on the left. I'll look into that though. Okay, so we now got all these mean ratings, and awesome. We now have like an indicator of how heavy and how light things are. I quite like the idea of having like 0 being a colour's neither heavy or light. So to calculate like the relative lightness, I don't recall the formula that I used, but it's super simple. I just took the average of all these values along the top, and I subtracted it from the mean. So it's a super simple formula. And yes, those are the values which we used in the word color to compute the correlation. So minus 160, minus 160. Okay, so yeah, hopefully I've clarified things a bit. So I'll just check over, check through this sheet. I've only got 10 minutes on this free screen recorder, and I've just finished the 9th minute. So maybe within 50 seconds I can explain what I did. And simply what I did was I took all of these values and I piped it into an ANOVA, with colour being one factor, so we had 14 colours, and orientation, left or right, the box that is, being another factor. And lo and behold, we find an effect of colour, and that effect of colour simply means that we have